So in this transducer engineering, the second unit is characteristics of transducer. So transducer characteristics majorly segregated into two ways. One is static characteristics and another one dynamic characteristics. Static characteristics. Static. With respect to input and output relation, the characteristics are analyzed with respect to in a static way. So for static characteristics analyzed by different parameters. One is accuracy or precision, resolution, sensitivity, linearity, span, and range. So these are the parameters are used to analyze the static characteristics of the transducers. And another one, dynamic characteristics. And in a mathematically, the transducers are classified either zero order transducer or first order transducer or second order transducers. So this is how we can assume or identify the transducers either in zero order, first order or second order means with respect to the transfer function order. So the type based on that type of order, based on that order, the transducers are classified or identified either zero order transducer or first order transducer or second order transducers. So the transducer response are analyzed with a different kind of parameters, input parameters. For example, impulse signal or step signal or ramp signal or sinusoidal input. With respect to these kind of standard inputs, we can able to analyze the response of the transducers. So these are the standard step signals. Standard test signals are step or ramp or impulse or sinusoidal input. Okay, so we know the step signal means if input is the time interval is 0 or greater than 0, the corresponding amplitude is in A. Unit step input means the amplitude is equal to 1. And ramp signal, with respect to unit step signal, the ramp signal and the unit step signals are related. R of t is equal to t into u of t. Am I right? So the input time interval is linearly varying with respect to output amplitude. That is a ramp signal. Okay, so mathematically it is expressed by R of t is equal to if a t greater than or equal to 0 means the corresponding amplitude is a t into u of t. Okay. If a t less than 0 means the corresponding amplitude is 0. Okay. And impulse signal. So impulse signal means at the time t is equal to 0, the amplitude is 1 unit impulse. Otherwise, amplitude is generally expressed by letter A. If a time not equal to 0 means the amplitude is 0. That is the impulse. And sinusoidal signal we know. So the amplitude is continuously varying with respect to time. Sinusoidal, it has a positive cycle and a negative cycle. We can take one cycle. Okay, sinusoidal. Okay, x of t is equal to a into sine omega t. The a is the amplitude and omega is the frequency 2 pi f. So from this we can analyze the sinusoidal signal. So these are all the standard test signals are used for analyzing the response of the transducers. So performance characteristics of instruments, static characteristics. So in this, all the static performance characteristics are obtained by one form or some another form of a process, which is called as calibration. Okay, so calibration is a method. It's a process which is used to analyze the static performance characteristics. Okay, and the main characteristics are generally accuracy, sensitivity, resolution, precision, drift, static error, dead zone, etc. etc. So we can see one by one. See first accuracy. It is a measure of closeness with which an instrument measures the true value of the quantity. Accurate value. So closer to the true value or absolute value. That measurement is analyzed by accuracy. And precision, it is a measure of consistency or repeatability of a series of measurements. It is like as a mode. So which values repeatedly occur while measuring one length more than or n number of times. So okay, out of n number of times, which reading is occur frequently, repeatedly. So that is precision. Okay, and sensitivity. It is a measure of change in reading of an instrument for a given change in measured quantity. Changes. So changes in the reading, which is analyzed as sensitivity. Okay, and finally resolution. So it is the smallest changes in measured quantity that will produce a detectable change in the instrument reading, absolute reading. So that is resolution. And so these things already we know, we studied in first unit, error concept. That is the error means the deviation between the absolute value and the true value. Okay, so that is error. Okay, so absolute error is equal to x of e minus x of m. So x of e is the expected value and x of m is the measured value. So the difference is called as absolute error. Okay, and then range. So range is a some limitation, limit of magnitude. Okay, so plus or minus 5 or plus or minus 10 or plus or minus 0.5 or 1 is acceptable. That is a range. Okay, and span. So it is an algebraic difference between the upper limit and the lower limit of the instrument range. Okay, for example, in a galvanometer, uh, actually the span is 20 milliamps. So the range for 20 milliamps means the range is from minus 10 milliamps to plus 10 milliamps. Okay, so that is the range or span of galvanometer. And another thing, dead zone. So it is nothing but the largest change in input quantity for which there is no change in output. If a changes more occur in input, but it does not affect any output. Single effect does not affect a single in output. That is dead zone. Okay, then that is the meaning of dead zone. Then threshold is a limitation. After the threshold, the input is output is increasing linearly with respect to time. So what is the threshold value? If this question is arise to maximum. So the input into the measurement is increased very gradually from zero. There will be some minimum value below which no output change can be detected. Okay, so that is some limited range on a specified value, that is the threshold. Okay, so the minimum value defines the threshold of the instrument. And significant figure. So it is nothing but the number of significant figure indicate the precision of the instrument. Actually, it is a numerical result of a measurement. Only those figures are meaningful should be recorded. Okay. So these are the static characteristics. So the major thing: accuracy, precision, sensitivity, resolution, error, range, span, dead zone, threshold. Okay. So these are all the things or static characteristics of the transducer. And the basic of dynamic characteristics, the major thing is a step change, linear change, and sinusoidal change. Okay. So it can be determined by applying some form of known and predetermined input to its primary element and study the output. So the primary inputs are step input and linear and sinusoidal. So the first one first one shows the step input, and second one linear, and third one sinusoidal. Okay, and so in this lead and lag compensator or lag, how do you analyze the lead and lag concept in a transducer? So this is lag means it is a delay of the response of an instrument to changes in the measured quantity. Okay, so here two types is there. One is the retardation type and another one time delay type or dead time. Okay, so retardation type, in that the response of an instrument begins immediately on a change measured value. Okay, if a changes is occur in this measured value, so the response is the changes in the response are immediately we can identify. Okay, next, in a time delay type or dead time, the response of the instrument is simply shifted along the time scale. Okay, so that is the difference. Immediate identifications are immediately we can identify in a retardation type. In a time delay type, just in the time scale readings are shifted, that no effect in this response. Okay, so this is the time delay type or dead time. And dynamic error. So it is a difference between the true value of your quantity with respect to time. So with respect to time, the response is varying. It is not in static. So that's why it is called as dynamic error. Okay. And fidelity. So fidelity, it is a determine the fact that how closely the instrument reading follows the measured value. Otherwise, it is a degree to which an instrument indicates the changes in measured variable without any dynamic error. So this is fidelity. Okay. So this is basic things in static characteristics and dynamic characteristics of a transducers. Okay, thank you. Sir, 3 unit